Hi tennis. I think this is going to be a long one, so get yourselves comfortable. Okay, open your notes at page 42 for me. Okay. Now, I'm not even apologising for the fact this might be a bit longer because this is something that a lot of people misunderstand so much, and I am determined that we are not going to be those people. We are going to totally follow what is going on here. Yeah? Okay. So, um, in one of those questions you were doing yesterday, you ended up having to put information into groups, and that's the type of stuff that we're talking about here. So if our original data that we're given is in groups, then it means we're lacking a little bit of detail, and it makes it so much harder to figure out all those averages that we were talking about yesterday, like the mean and the median and all that. So there's a couple of little things that we are going to have to get used to doing here. So this is the notation that we're going to be using whenever we're calculating the mean, but I'm not even going to mention that just yet. I will in a couple of minutes, but for now I want us to get our head around what this information actually means. Okay, so in this little example here on page 42, the number of games that children had for their games console is given in the table below. Estimate the number of games that each child has. So that's really, that should have said estimate the mean number of games, so let's add that in. So if you write that in there for me as well, please. So estimate the mean number of games that each child has, because that's what we're looking at here today. So this information actually means, right, there's 5 children that have between 0 and 5 games. There's 9 children that have between 6 and 10 games. There's 17 that have between 11 and 15, etc, etc, etc. Now, if I was to ask you how many children have 13 games, well, we don't actually know, and that's where the problem arises whenever we have grouped data like this. We're lacking that detail in it. So what did I say, 13? We don't know how many had 13. All we know is that there's 17 of them have either 11, 12, 13, 14 or 15. And it's because of that unknown value that questions like this will always be worded estimate the mean. It doesn't mean you just guess. It absolutely does not. It means that you carry out this process here that that we're about to do, and all this process does is give you an estimate, because we don't know the individual pieces of information. So to get a proper mean is impossible. Now, there's another wee thing before we get cracking onto this actual process. There's another wee thing I want you to change for me, okay? So see here with 0 to 5, can we change that so that this group is 1 to 5, right? That's a wee mistake. So, because we don't know all the individual pieces of information, all we can do is pretend that every one of these 5 is smack bang in the middle of this group. So every one of these 9 is smack bang in the middle of this one. And the reason that we do that is because there's likelihood that so let's look at the 6 to 10 one. The likelihood is that these 9 are spread relatively evenly, and that's the assumption that we're making throughout this group. So a couple at 6, a couple at 7, a few at 9, left out 8, a couple at 8, a couple at 10, right? So what we have to do is pretend that they're all at the midpoint in the hopes that it all will even itself out. So we need to add on an extra column here that is going to be the midpoint. Now, we use the letter X for that. You'll see how we use it in a little bit. So 1 to 5, 1, 2, 3, 4, 5. The middle of this group is 3. So we're assuming that all 5 of these have 3 games, in the hopes that there will be a range of them, but that should even out. The higher ones should balance out with the lower ones. We'll go again to find the middle. 6, 7, 8, 9, 10. 8 is the middle of this group, 6 to 10. 11, 12, 13, 14, 15. 13 was the middle of that group. Now, you could keep doing that for the rest of these. However, all groups aren't going to only have 5. It's not always going to be as easy to count like that. So see, with information like this, do you notice how if you add these two together, you get 26, and divide by 2, 13. 6 plus 10, 16. Divide by 2, 8. 1 plus 5, 6. Divide by 2, 3. So the same is going to work for the rest of these. So 16, 17, 18. Add these two together gives you 36, divide by 2 gives you 18. So we can fill out the rest of those like that. This one's going to be 23 and this one's going to be 28. Okay, now I know I've said this a million times, it must be really boring, but I don't care. Well, I care if it's boring, but I really want you to get this. So what we're saying is we're pretending that all 9 of these people, because remember frequency just means the number of things you're talking about, all 9 of them have got 8 games. Even though we know that's not true, we know that it's just 9 of them have between 6 and 10. We're pretending that all 17 have 13. Now, the next column that we have to add on really is like counting up all the games. So we're pretending there's 5 people that have got 3 games, so that's 15 games altogether. There's 9 that have 8 games, that's 72 altogether, right? Now, here's where we get to be a wee bit mathsy. I'm not going to write in here total number of games, okay? What we do here is we always just call this column fx. So f stands for the frequency, which is the number of the things that you're talking about, and x is the midpoint, and fx just means frequency multiplied by midpoint. In fact, let's write that in. So this means frequency multiplied by midpoint. So 5 multiplied by 3 gives us 15. 9 multiplied by 8 gives us 72. Let's do the rest. Okay, so there's the rest of those filled in. Make sure you get them filled in as well. Now, to find the mean, what we have to do, remember, is add up all the stuff that we have and divide by how many of it we have. So, do you remember I said this column here was like the total number of games, because we have 5 people we're saying had 3 games, we've got 9 people we're saying had 8, etc. So if we add up all of these, this will give us an estimate for the total number of games for this whole situation, right? Let's do that. Okay. Right, 10s, that number I have written there is wrong. I do notice later on in the video, but I just wanted to warn you now before you all wrote it down incorrectly. So that column, that fx column, actually adds up to 1575. I've written 1675 here, but as I say, I fix it later on. Okay, so 1575. Right, back to it. Okay, so I got that 1675. Now the way that we label this looks really fancy, right? Sigma fx. So this wee symbol here is this wee symbol up here, and it just means total of or sum of. So sigma fx means the total of the fx column, and in this case that's talking about the total number of games all together in this situation. So the total of the games is 1675. Now, if we're trying to calculate the mean, we need to add up all the games, we've done that, and divide by the number of people that we're talking about. And that's going to be from the total of this frequency column, because this 5 means 5 people, this 9 means 9 people, 17 people, 28 people, etc. So I'm just going to add up this column here now. So this is talking about 90 people. So the sigma f, the total frequency, is 90. I want to add in a couple of little labels here just so we don't forget this, because remember, this is the type of thing that people forget all the time, and we're not going to do that. So I need you to add this in as well. So just a reminder that this means the total number of children for this situation, and this means the total number of games that we're talking about. So if you get that added in. Okay, now we can finally get on with this mean calculation. So this is how you need to set your working out with, or for this. So the mean, and remember we're being asked for the mean number of games per person. So the mean is going to be sigma fx divided by sigma f. And again, I'm making you label it. Sigma fx means total number of games. Sigma f, total number of children. And the reason I'm going on and on and on about this is so that you see what's going on and you're not just like blindly following instructions, because if you're doing that, you always forget stuff, whereas if you can actually understand it, then if you get stuck, you're more likely to be able to figure out what to do. Okay, so sigma fx is 1675, sigma f is 90. So if I do that, 1675 divided by 90, do you see the way I get 18.611111? 18.6. Now, oh, sorry. Depending on the question, sometimes you might want to round that to the nearest whole number, because you can't really have 0.6 of a game. So approximately 19 games. Year 10. I've just noticed a mistake in my work. This here actually added up to 1575. I'm really sorry, can you go back and change that? Well done if you spotted that before I did. I must have just typed something into my calculator wrong. I'm really sorry. So this total here was actually 1575, which means you'll need to change it here for me. And then that gets you 17.5 games. So I'm going to round that up to 18. Now, what prompted me to actually check that was I was about to say to you, always check your answer is sensible. Okay, so see if we look back up here. This here's the range of games that people had. So if our answer came out to be 64, right? Well, there was no people that had that many games, so it's really impossible for our average, or sorry, our mean to be that. And I actually thought whenever I saw the 19, ooh, that's maybe a wee bit high. I know that 18 isn't much lower, but see if we look here, we've got a load of people here at the higher numbers. So I suppose it makes sense for our answer to be towards the higher end of the range that we have here. So again, apologies for that wee typing into my calculator. Should I check it again? I'm gonna check it again. Yeah, 1575. Honestly, I don't know what I did. That does remind me though to remind you that in all these statistics questions, because there's a lot of typing into your calculator and adding up, there is a lot of opportunity for you to make a wee silly mistake. So I do want to say, if you're getting questions wrong, it's not that you don't know how to do it, it's probably just a silly mistake. Sure, even experts like me can make those silly mistakes. Right, let's have a wee look at the questions you're going to be doing. So really annoyingly, in your textbook, these tables are given to you in a horizontal fashion. You need to redraw them. So whenever I'm looking through your class workbooks, I should see for all these questions that you have redrawn. I'll show you how I would draw the first one here. Right, so this first question is about number of bad peaches per box, right? So you need to draw it vertically like this, and then remember you need to add on those 2 extra columns. So you've got your frequency columns. There's 34 times that there was 0 to 4 bad peaches per box. There's 11 times there was 5 to 9 bad peaches per box. Okay, so then after that you need to add on your midpoint, which remember we call x, and then our fx column, which just means frequency multiplied by midpoint. Then quick reminder, you're going to total this column, sigma fx, add up all these, hopefully better than I did in the example. You're going to add up this column, sigma f, add up all these, and then to get your mean, it is sigma fx over sigma f. So the first few questions are like that, and then question 4, just to add a wee extra bit of confusion, it doesn't give you the frequency in a table, it gives you a bar chart. So you're going to have number of defective screws, frequency, and then you're going to have to read your frequency off this bar chart. Okay, so for each of these you have to find an estimate for the mean. It's just the same as that example. Okay, I'll give over now and let you get on with it. Bye.